Hello friends, welcome once again the paper wave and optics second. Last time we have discussed about the lens system and this there was formula, that is a Gauss formula we have discussed, and the Newton's formula today we'll discuss. Okay, so this is the Gauss formula, that is the 1 by V minus 1 by U is equal to F, and how to work when the light is coming from the object and incident on the lens, how lens will be behave, that we will have discussed in the earlier case. Now today we'll discuss the graphical construction of the image. Let us consider this is the principal axis of the lens, and here we have the AB is the object. So AB is here, yeah, this is the object, and object have the height h1. Please keep in mind this is the height of object. So whenever the light is coming from this object and which is incident on the lens, so some point will be created on that principal axis. That points are known as the cardinal points, and we are familiar with this point. So here we consider that this is the point h1 on the principal axis. So this is the principal point, and we can give the name as an h1 for the principal point 1. And this is the p1 point where the light coming from the height of the object, which is coming from this and which is incident on that particularly plane. This is the plane of principal 1, our first principal plane, you can say that. By this geometry, we can write out the equation, so that AB is equal to P1 H1, which is equal to H1. So this distance is equal to this distance because they are parallel to each other and have the on the same principal plane. So that similarly, which is light is going from here point P1 to point P2, and here it will be formed the another plane that is called as a second principal plane at this point h2. So this is the principal point on that principal axis. Okay, so here this distance h1 p1 is equal to h2 p2 because they are the parallel line to the principal axis. This ap2 is a parallel to the this bh2, so that I can write down the equation ab is equal to p1 h1, which is equal to p2 h2, which is equal to h1. Now this line is light is coming and which is again incident at or emerge out at the point f2. So here we will get the second focal point, and if you draw the line here, so we'll get the focal plane, that is the second focal plane we'll get. Okay, so here another line is coming from this point A and emerge out at the point N1. So N1 is the first nodal point of the on the principal axis. Please keep in mind. So it will be interact. It will be interact at this point. That is a S1. Okay. So similarly, we can uh, find out the S1 to S2. So just I can draw the normal from this in between the two planes, so that this h1 s1 is equal to h2 s2. That distance will be the same. So I can write down that one. So that equation becomes s1 h1 is equal to s2 h2. So that because of the normal I have drawn from this between the two plane. That is a principal plane, and therefore if I use that geometry, and from this I can draw the line here, and which is bit at point which is coming from the P2, and we will get here the image point of this object. So this object image point we will get here. So that one we can draw the point here, that is the which is coming here, and here we will get the nodal point second. And if you draw the again plane from this, we will get the nodal principal plane. So this is the first plane, and this is the second nodal plane. Please keep in mind. Okay, so we have the angle, this both angle, that is the AN1 and H1. So this one, this angle is equal to this angle S2, N2, H2. So both angles are the same angle. So just I can write down here, so both are the angles are the same. Okay, please keep in mind. Now the another line is coming from the top of the light, and it will be coming through this focal line first, or focal point first, and which is emerge out at the point T1. So please keep in mind this line is coming here, and we have considered here the focal point 1, and this is the focal point 2nd. Okay, so we can draw the line, this one, that is a T1 to this point. So whenever it will be made together, so that we have some geometrical points, and here we will get the T1H1 is equal to T2H2. So that distance, this distance is equal to this distance. Please keep in mind this distance are equal, and this A1 is point representing the image part of this object A. So this A1 is representing the image of A, image of A. So just I can write down the here. So this is the B, so I can use here the B1 because I have used here A, and so this is the height is the H2. So that relation we can check. So we have already considered that this distance is equal to this distance, so that this distance is equal to this distance, and that is equal to H2, that is equal to H2. So we have the equation here. So what is the relation between the H1 and H2? So F1 H1, so that is the F1 H1, this distance is nothing but F1, and this distance, that is this distance is nothing but F2. So I draw this line here. So this distance is equal to F1. So small f1 I can use here, and this distance, this distance is called as an f2. It's called as an f2. So this is the distance. So on this basis of the parameters, we can find out the graphical construction of the image. So that now we can consider that this distance, now this distance we can consider that x1, and this another one is called as an x2. So we will find out the what is the distance between the x1, x2 and f1, f2. So that is our aim. So simply we can consider the b1, f1, so that we have already considered. So in this triangle, that is a abf1. So triangle abf1, I'll just show you abf1. So this is the triangle, please keep in mind. Okay, so this is the triangle, and in that triangle is a right angle triangle, we know that. So this is the both are the AP1 and BH1 are parallel to each other, so that this will be 90 degree. So that we can use that theorem, and we can write down the equation, that is AB upon T1 H1, AB upon T1 H1. So, this triangle we can consider that. So both are the triangles, and AB upon T1 H1 is equal to BF1 upon H1 F1 H1 F1. So this is the distance. Okay, and similarly we can write down their notations as per we have given, that is H1 by H2 is equal to X1 by F1. Okay, so this is the X1 and this is the F1. Okay, so that we can write down this. Similarly we can consider these two triangles, that is the A1 B1 F1. So here A1 B1 and F2, sorry, here you can consider as an F2, so that is one by mistake here, so please consider here F2, and triangle P2 H2 F2. So this triangle P2 F2 and H2, so this is the triangle. So both the triangles. In the triangle, similarly, we can use the same notation and we can write down here the equation, that is the H1 H2 is equal to F2 X2. So we have the equation here H1 H2 and here also H1 by H2. So that we can compare and we can write down the equation simply. H1 by H2 is equal to F2 by X1, which is equal to X1 by F1, and we can similarly write down here, so this part only, so by this part we can write down the X1 X2 is equal to F1 F2, and if is there, okay, this is called as a Newton's formula, and if the F1 and F2 are equal, then we can write down this equation, that is called this equation x1 into x2 is equal to f square. It is only for same medium at both sides. So suppose this is the lens, so if it is the lens, this is the lens part. Okay, so this is the lens part, so this is the in the medium, and this part is the air medium. Suppose this is the air medium, yes, okay, so this is called as an air medium, and if it is the lens part, then it is a mu medium, I can say that. So that in that case only we will get the same relation. So this is called as Newton's formula, and by that way we can find out where the image will be formed. So now we can stop it here. Thank you very much.